Pew, pew, pew. Pew, pew. Let's do some logarithms. So this is check on learning section whatever point one. Was it 8, 9? 9.1. Yeah, that's it. I knew that. I was just testing you. So remember, we are learning about and are getting comfortable with logarithms. So you will see logarithms forever, both in your mathematical academic career and in your scientific academic career. So get used to them. So it says complete the table for the values of -2 to 2 for the function f of x equals 3x. Blah, blah, blah. Part A. Complete the table. F of x equals 3x. So, first off, we've got 3 to the power of -2, which is also the same as 1 over 3 squared, which is 1 over 9. So we'll make that into a fraction. Their squares here are just absolutely wonderful. So then we have 3 to the power of -1, which is the same as 1 over 3 to the first, which is the same as 1/3. Uh-oh. 1/3. So then 0, 3 to the 0th power, anything to the 0th power equals 1. 3 to the first power is going to be 3. 3 to the second power is going to be 9. So I hope you don't mind that I didn't write those out. And just to double check, that's not the right tab. One over 9, 1 over 3, 1, 3, 9. So then moving right along, which of the following graphs is the graph of f equals 3 of x? So we just take our points and figure out where they lie. So I'm just going to do 0, 1. Okay. So I'm just going to write these on the screen. 0, 1, 1, 3, 2, 9. I bet you if those 3 points are on there, then we're good to go. So 0, 1, 1, that's like 1, 6. So it's not that one. 0, 1, 1, 3, 2, 9. So I'm willing to bet that it's that one, but just for fun, we'll eliminate the other two. So 0, 1, we're good here. 1, 3. Oh, that's 1, 2. Oops. So this point right there is 1, 2, not 1, 3. So that was my bad. Thought I checked. So over here, got 0, 1. That's good. 1, that's 1, 4. So it's not that one. No, it's that one. So use the values of the graph to complete the tables for g of x equals log base 3 of x. So when we plug what number in, will we get -2? So you can either, well, you can't plug this in your calculator, but you can either try to rationalize this out, turn it back into an exponent, or you can remember that the log is the inverse of our function right here. So all of these x values are going to be now our y values. All of our y values are going to be now our x values. So for -2, it was 1 over 9. It's hard to see, but I'm pretty sure that's going to be a 0. I don't know. Let's check up here. Gosh, these boxes are hard to see. Maybe if I zoom in. Nope. Oh, it's 1/3. So then that's going to be -1. This is going to be 0. This is going to be 2. And this one's going to be 3. Again, I'm getting all of my values from up here. I know that it's the inverse. So which of the following graphs? So let's write some of these down. So I've got 1/9, -2, 1/3, -1. Let's get some real points that I can actually find. Here we go. So let's see here. 1, 0. What's right here? 1, 0. 3, 1. So this is 3 less than 1. So not that guy. So 1, 0. 3, 1. Still not this guy. 1, 0. 3, 1. So it must be here. And let's just verify. 1, 0. 3, 1. And then 9, 2. Yep. So there's our graph. What is the relationship between the two functions and their graphs? The functions are inverse functions, true. So the ordered pairs that belong to each function are those of the other function with the x and y coordinates reversed, true. This means the domain of f of x is the range of g of x, and the range of f of x is the domain of g of x, and vice versa. Their graphs are reflections across the y equals x axis. I like that. So as I go down, whatever, their graphs are reflections across the line y equals 1. That's false. There's no relationship. That's false. Their graphs are reflections across y equals 0. That's false. So there we go. That's our first one. So now it says find the exponential equation express the exponential equation as a logarithmic equation. So remember, it's log base number of that is going to give us the exponent. So if we write that out, that's going to be log base 16 of 2 is going to equal 1/4. Log base 16, 2, 1/4. And there you go, log base 16 of 2 equals 1/4. Next. So this is the same thing, and I hate how they switch from fractions to decimals, but whatever. So same thing here. So log base 0.25, and they want you to keep it in a decimal spot, whatever. Log base 2.5 of q equals 5. So log base 0.25 of q equals 5. Log base 2.5 q equals 5. So again, it says, so this time we have the log, we have to turn it into an exponential. So log base 12 of that number. So these you can always check with your calculator too if you wanted to. Just stick 12 to the power of 3 and make sure that it's true. oops, 12 to the power of 3 equals 1728. By 3 equals 17.28. Or, I'm sorry, 1728. Just chugging through these. Again, find the exponential equation. And so don't let these letters scare you. It's all the same exact process. So log base 3/4 to the power of y is going to equal x. 3/4 raised to the power of y. And of course, this equation looks super crazy, but it is what it is. It looks better with parentheses. I'll give him that. I'll give him that. Parentheses are your friend. That makes the equation look way better and easier to understand. If f of x equals log base 5 of x, find f of 625 and f of 1 over 125. So log base 5 of 625. So log base 5 of 625, equals, we'll just say y. So again, if we're going to switch that to an exponent, it's going to be log base 5 to what power is going to give me 625. So I don't know. So I don't know that off the top of my head. So what I would do on my calculator, and this is again because I'm bad at basic math, so I need to figure out how many times I multiply 5 together to get 625. 1, 2, 3, 4, 4. So y equals 4. So you saw what I did on my calculator. I just started counting and 4 until I got to the right number. So this one's going to be 4. And f of 125. So it's going to be log base 5 of x. So log base 5 of 1 over 125 equals, I'm just going to make it say y. Change it to an equation. So 5 to the power of y. And when is that going to equal 125? So over on my calculator, I saw 125 show up. That was 2, 3. So that means if we say y is -3, that's basically, so if we say 5 to the -3rd, that's like saying 1 over 5 cubed, which is 1 over 125. So y is going to equal -3. Or -3. So we got a good word problem here. Loudness, L, is described in decibels of a sound modeled by a log function where I is the sound's intensity and I naught is defined. What is the loudness of decibels in the subway whose sound intensity is blank? So we've got an equation, and I'm just going to plug everything we know straight into it. L equals 10 log of I, which is right there, 10 to the -3rd over I naught, 10 to the -12th. This should be a 3. And so hopefully you remember our exponent stuff. So that's the same as 10 log. Remember, there's no number right after the log, so it's assumed to be log base 10. So let's see here. Negative 3 minus a negative 12 is going to be plus 12. That's going to be 10 to the 9th. Yeah. So then, if we say, we'll use L, we can turn it into a fraction if you want. The answer is going to be 9, because I can see that right there. But it's, so we can divide the 10 over. So L over 10 is equal, whatever, log base 10 of 9. So that's like saying log base 10 raised to the power of L over 10. And when does that equal 9? I think that doesn't seem right. Log base 10. So let's see, what is that? Log base 10 of all of that. So something like that. So then we have L over 10 equals 9. So then L equals 90. So I'm not entirely sure of my math there, so I'm going to double check it. And it will also give us a good opportunity to see it done on a calculator. Where did my calculator go? So we've got, I'm just going to plug this equation in right here. So it says L equals 10 times log base 10 of 10 to the 9th equals 90. So I was right. I'm not going crazy. Nine zero. Just to double check. 90 decibels. So the amount of radioactive isotope cesium-137 in the environment since 1950 is known. Plants take up cesium-137, which reveals information about when a plant was growing. The function m equals m naught times 1/2 and other stuff describes the mass m of cesium-137 remaining after t years, there's your t, from the initial amount mass naught. After how long will that many micrograms of cesium remain from an initial amount of 0.1 microgram? Okay, so we got to start plugging stuff in. So we got an initial amount, m naught equals, let's go ahead and write it over here. M naught equals 0.1. M is the mass after however many years. In our case, m is equal to 0.025. So then we just plug all that stuff in. So we've got 0.025 equals 0.1 times 1/2 to the power of t over 30.1. So originally when we saw something like this, we'd have to like graph it and basically find the point of intersection. Now we have some math that we can do to figure this out. So step 1, divide both sides by 0.1. So I'm just going to use my own calculator. 0.025 divided by 0.1. So we've got 0.25 equals 1/2 to the power of t over 30.1. So now we can express this as a logarithm. So that's going to be log base 1/2 of 0.25 equals t over 30.1. So I'm going kind of the wrong direction, but whatever. So now we can multiply both sides by that 30.1, switching to blue. So now we have 30.1 times log of 1/2, or log base 1/2 of 0.25 equals t. So that means, again, so now that that 30 is on the other side, we can start to put it back into an exponential form so we can understand it a little bit better. So we've got, and I'm just taking this part right here first. So that part is saying log base 1/2 raised to the power of t equals, I'm going to change this decimal into a fraction as well, 1/4. So in this situation, our t is going to be equal to 2, right? And do we need to do anything with that? I assume we probably do. Let's check. Yeah. So we got t equals 2 for this part right here. But we've got that 30, so where would that go? Okay, I got it. So we're going to erase this stuff. So starting here, so we can rewrite, let's get rid of that part. We can rewrite this part as first log base 1/2 of 1/4. Then we can rewrite it as log base 1/2 of 1/2 to the power of 2. So then all of this turns into 2. So then you have 30.1 times 2 equals t. So sorry about that it took me a minute to remember that. But then you've got the 30.1 times 2, which is your 60.2. So logs. Let's do more logs. We will do more logs when I see you in class. Take care, everybody.